Hey everybody, we're going to go over Notebook 4, and this is going to be about table tools. So go ahead and get Notebook 4 open. And while you're getting that open, let me point this out. I posted this announcement in D2L because I'm concerned that not enough people are taking advantage of help. There are online help sessions, 6 p.m. on Thursday evenings and 10 a.m. Friday mornings. There's online lab help sessions. I'm available in Teams. I'm also available by appointment. We can text chat or video chat as needed. Um, and you're allowed to ask questions about these assignments, these labs and homeworks prior to the due date. And not very many people are doing that. About maybe 25% of the students in the class have contacted me with questions. And by the way, those students are ones who are doing very well. So, word to the wise, it appears that asking questions of your professor helps. So again, go to the course calendar now and make sure that you are in Notebook 4, Table Tools, and that looks like this. Okay, so I am just getting the um, initial code block run. And let's take a look, okay? So we're going to start with a review of arrays, all right? And we're going to use make underscore array. We're also going to learn how to use dot item. And it turns out that we have a special uh, code that we can use instead of typing out dot item parentheses 2. We can just use the square brackets. Also, we're going to review a little bit about some functions that we can use with these arrays. And here's one key learning point that's new today. We're going to learn NP arange. Um, Not a range. A range would have two R's. This is NP arange because it creates a range of values. And it is a very useful tool, and we use it quite a bit in the course. So that's what we're going to talk about. Let me get rid of the ink and switch back into our notebook. Okay, so to review arrays, remember I just use make array and then I list the values that I want separated by commas, and you can see the result is exactly that. It tells me the data type, it is an array. Heights divided by 12. Remember, when I have an array and I do addition, subtraction, multiplication, division, it just does that operation to every single thing. So 60 divided by 12 is 5. All right, so these numbers are just um, divided by 12, okay? Now some of the heights, remember this doesn't actually change the heights, okay? So real quick, I'll do this. Remember, you can hit the plus sign and open up an extra um, an extra code block if you want. Remember, you can also open up an extra code block, switch to Markdown, and then you can type your notes. Remember, um, making this point because you do have your own personal area in the UNG Data Hub, and this file will be saved in your area of the Data Hub with your changes, okay, as long as you hit save right here, and it'll create a checkpoint and save it. And so you can either type notes right here or take notes, you know, hard copy or something if you want to write into a notebook. Okay. Um, and you are allowed to do that. And I'm just getting rid of this, going back to normal. So the point there was that this operation didn't change what's in heights. It changed what's displayed in the array. It did the arithmetic, but when we sum up the heights, notice that it's going back to these and giving us a value of over 300. Where if the heights array had changed after this operation, the sum would be much lower. Okay. So NP average height, same thing. It's going to take the average of these values. And by the way, we've got a couple different things we can do. Sorry, let me just copy paste this down. I opened up the code block. We can do in the wrong place there. we can do NP mean, okay? It turns out that it will do both average and mean, and 99.9% of the time in this class, these are absolutely indistinguishable. And mean is shorter to type, so a lot of the students prefer that. I'm going to get rid of it again. This is what's in our notebook. This is the one we use most in the course, but np.mean will also get the average, okay? Here's a strings array. And notice that it still says it's an array, it's just there's a different data type inside the array. That's what that extra code on the end means. Okay, and now we're going in here to heights item 4. So let's do this up here, right? So heights item 0 is this, 67. And then item 1, item 2, item 3. So when we do this, we're going to get 65, right? And notice this is what I made a note of in the PowerPoint, right? That instead of doing dot item 4, I can do square brackets item 4, no dot in there. And you're like, well, why do we do item 4? Well, it turns out that the square brackets version doesn't always behave the way we'd like it to. Okay, so I use this one all the time myself just because it's more of a fail-safe method that it will work. If we have an array, it will go in there and grab the right one. And I don't use this one very often because again, it's rarely that it fails, but it does fail sometimes. And so that can be confusing for students. So my suggestion, just always use the dot item 4, and then we'll know that it's going to work properly. Okay, strings array, item 0 is the first one, correct? Now, MPA range, all right? So MPA range 6 is going to give me a range of 6 values. It always, if you don't specify a starting criteria, it always starts counting at 0. And please notice that it stops 1 unit before the stopping criteria, right? So our stopping criteria was 6, it stops at 5. And notice it does give me 6 values. There's 2, there's 4, there's 6 values, right? Because it starts counting at 0. Okay, so we can specify more. When we specify extra numbers, it's start criteria, stopping criteria, and the increment value. And that -1 means that it's going to count backwards from 15 down to 7. Okay, and there we go. Only it didn't count down to 7. Remember, it always stops 1 unit prior to this stopping criteria. So it stopped, if it had gone 1 more unit, there would be a 7 here, but it never shows that 7 because it always stops 1 unit before the stopping criteria. All right. NPA range. Okay, so we're going to start at 0. We're going to count up to 20 by 2s. So I bet we'll only count up to 18, but let's see how this works. And there we go, 0, 2, 4, all the way up through 18, stopping 1 before the stopping criteria. Okay, NPA range. This is going to start at 0, go up to 1, and count by tenths. So these are all the tenths between 0 and 1, but remember it'll stop at 0.9. It stops 1 unit before the stopping criteria. We get rid of the ink so we can see that better. And NPA range 8 is going to do the same thing as NPA range 6 did. It's going to start counting at 0, count by 1s up to the 7, which is 1 unit prior to the stopping criteria. And what is units item 7 in the A array? Well, it's 7. Remember, it starts counting at 0, so this actually the numbers are their item numbers as well. Okay, so NPA range is an extremely useful tool, and I went over it quickly, but remember it has 3 values: start, stop, and increment value. And if I just list one, it's the stopping criteria, and it will automatically start counting at 0. Okay. We have another new topic that we're going to be talking about. And mostly we've just imported our tables, but we can create a table from scratch. Okay. And how do we do that? Well, we have with underscore column and with underscore columns. They behave pretty much the same, except obviously the second one allows us to do multiple columns, to add in multiple columns to the table at the same time. And then we're also going to review some things that we've talked about, num rows and num columns. And also, this is a cool one, labels. It will let us know the names of all the columns. So usually the column names are variables in the data set. So it's going to let us know what type of variables we have to work with without having to scroll through the entire data set. And also, when we do import a data set, we use table.readTable. Okay. So let me get rid of the ink and let's jump back into the notebook. So here we go. We're going to create a table from scratch. The first thing we're doing is we're creating an array, and these are going to be street names. Okay. Chestatee Park, Metters, and Grove. Okay. And now look, Southside is going to be a table. Now look, this table, empty parentheses, it's just a placeholder. What do I mean? Well, we're doing a table method, but we don't have a table. So the empty table basically is what this is. It's just an empty table. So it creates a table. So Southside is an empty table. And then we can do a method on it. And so this with column streets, okay, this is going to create some streets for us. So let's take a look and see how that works. Boom. So notice that we have to give the column a title, and it does show up. And we have to tell it an array of data to go in, right? So this is the array of data that goes in. Boom. So table, again, is an empty table initially. The with column streets, comma streets, gives it the title to the column and the array that's going to be the column values. All right. So then Southside with column blocks for campus NP range 4. Interesting. So what it does is it does this NP range 4, and remember that the computer will stop counting 1 unit before the stopping criteria. It starts at 0. So NP range 4 does give us 4 different values, 0, 1, 2, and 3. Okay, and that's how many blocks from campus these different streets are. Okay. And notice we just use the same thing. We just use the name of the table dot with column. We give the column a title, and then we have to put in some array of values. Okay. And so now, but this is interesting. Why is the old table still here without the new column? Ah, well, here we go. Because now we're going to rename the table Southside to be equal to Southside with column blocks from campus with the MPA range. And then when we print out the Southside table, now the Southside table is updated. So remember, until we actually set the table Southside equal to something new, it's still going to be the same thing, just like it was above. But here we've set the table, the old table, equal to the new thing we created. And when we print it out, we get the new thing. Now, Southside labels, boom. This is really cool. All it does is gives us the labels or the column headings, right? And the column headings, again, they describe what data is in that column. So that description usually helps us understand a lot about the data set. So where this is really useful is, what if we have just dozens of columns, right? And then the problem is that to look at them, right, they're all over here. I'll put dot, 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 right? If we just have, 10 or 15 more columns over to the right, yeah, we can print out the table and look at the titles of all the columns, but it can take a lot of scrolling through to see all of these different titles. Okay, so let me clear the ink. So this dot labels method is really cool because it'll give me an array with all the column headings. And a lot of times this is a really quick way to see the type of data I have in the data table. Let me clear the ink again. Okay. And then south side num columns, it only has 2 columns, south side num rows. These are really cool. Again, for bigger data tables, num columns and num rows makes a lot of sense. And that way we get an idea of how big the data table is. And again, remember, show empty parentheses is show all, but I don't want to do show all if the number of rows is like 4,000, right? That's just too much data to deal with. Okay. So that's how to create a table from scratch, and we went over a review of a couple things like num columns and num rows, and we added in the new method, dot labels. Okay, and we're gonna go over some of these methods that we use all the time, dot sort, dot select, dot show, dot drop, dot column. Okay, we just use these guys all the time. And remember, we can open these tables using table.read tables. So clearing the ink, let's jump back in. Okay. So reading a table from a file. So we have this file called dubois.csv, and it's in the same folder. Again, if you click on File Open, you'll see that in the lectures folder, the revised lectures folder, there is this file. And so we just say, hey, table.read table. Notice that the table name has to be inside quotes. Single quotes or double quotes will work. Okay. So what do we have? So we've got some kind of demographics where we have class. Don't know exactly what the class means, but they seem to go up. And we have percentages that are spent on rent and food and clothes and taxes and other stuff. Then we have their status, whether they're comfortable or fair or poor or well-to-do. Okay. And average, so these look like they might be average weekly or salaries or something like that. We don't really know what this actual average is. But the rent and the food and the clothes and taxes and other, those are percentages. Okay. So which group class spent the highest percentage on rent? Okay, so we can just sort based on rent and add the option descending equals true. Okay. It also turns out that sort doesn't have very many options, maybe only the one. I don't know that for sure, but that's the only one I know of. And notice that if we just type true instead of descending equals true, it does the same thing. It sorts down the rent column based on the values in the rent column, and it does descending equals true. So I don't always have to type out descending equals true. Okay, it will be the exact same table if I just do this. Okay, so this is just a little quick trick. And I will jump back in here with descending equals true because that is in fact what we're doing. But there's a little quick method that instead of typing descending equals true, I can just type true, and the sort function, it only has one option, so it knows what the true is referring to. Okay. Now Dubois select. What does select do? Select grabs the status column. Okay. What does column do? The dot column method is the same thing as the select method, but instead of a table, dot column gets me an array. Okay. So, and these are the same. Dubois select status, column status. So I'm getting rid of them. Dubois column, actual average. Okay, so now we have these lists, and I assume that they're averages of money, right? Probably weekly wages. Okay, and Dubois column food. Again, these are percentages. And so what we're doing is we're taking the weekly average salary times the percent that's spent on food. And this is going to tell us for each group what actual percentage, right, is spent on food. Okay. Excuse me, the money that's spent on food. So instead of this being a percentage, now it's the actual money that was spent. Okay. And then what are we doing? Oh, so we're going to do food dollars. We're creating an array, which is Dubois column actual average times Dubois column food, right? So we're doing this thing and getting this array and calling it food dollars. And then we're doing Dubois with column, and food dollar is the name of the column we're going to add, and food dollars is the array that we're going to put in there. And then we're going to print out the new Dubois table, and here you go. We have food dollars. Okay, which is what? It's the actual average times the 0.19. And so we see that 19% of the $139.10 is $59.81. And so on and so forth. It does it for all of these all the way down. So when we are multiplying these arrays, notice that it's actually multiplying component wise, right? It's taking first component, I'm sorry. It's taking, yeah, first component times first component and giving us first component. And it's taking second component times second component and giving us second component, okay? So it did that multiplication um, down the elements. Okay, now this percent formatter, we don't use it a lot, but it's sometimes really helpful. So what are we going to do? We're going to take food, okay? We're going to say, hey, these are percentages. And what does it do? It just prints out the same thing that's in the column up here, but it prints it out as a percent, and it looks a little nicer. Okay, now what are we doing? Now we're using .select to get just a few of these. We're going to get class, actual average, food, and food dollars. Okay, so we're just going to print out 4 of these columns. Okay, and again, Dubois column food. Notice that the actual data is still there, exactly as it was, even though we did the percent formatter. The display changed, but the values are still in the table the exact same way. Okay, so we're gonna review a few more methods, and also one that's not on the slide that we're going to review a little bit is the dot where. And if you remember, the dot where helps us select rows. And there are predicates we use like r dot above or r dot between, r dot containing. So we use these different predicates to help us sort through which rows of data we would like to see. So let's continue on here. So we're going to grab the movies table, movies by year with ticket price.csv. So that's a real short file name right there for you. And remember show 5. So this is a really good way when we're first looking at a table. Hey, we go show 5, and there may be a lot of movies. See, they omitted 38 rows. There may be a lot more. Oh, and these are different years. So look what we have. So we have the year, we have the average ticket price that year, the total gross amount spent on movies that year, and the number of movies that were put out, and the number 1 movie of the year. Okay. So we learn a lot. Again, do we need to use num rows, num columns? Not always, because we can see in this particular one, and we don't need to use dot labels because we can see all the labels pretty easily. So for a small table, sometimes we don't need dot num rows, dot num columns, or dot labels, but they're really useful for big tables. Okay. Now, so they're going to take the gross in dollars. So they're going to take this total gross number and 1 times e to the 6. So I assume that means that this is in millions. And if we multiply by the 1 e to the 6, we'll add in the extra decimal places so it's an actual number that we can deal with. And then ticks sold equals gross in dollars divided by average movie or average ticket price. Okay, so if we take the total gross and divide by the average ticket price, we'll see the total number of tickets that were bought or tickets that were sold. Okay, let's see what we get. And then we're going to add movies.with column tickets sold. We're going to add a column. And so now let's show. Okay, there we go. And tickets sold, notice that it's switching to scientific notation times 10 to the 9th. Okay, so yeah. That's then 1.2 billion tickets sold, I think, if I'm doing my 10 to the 9th correctly. Um, and so yeah, lots of tickets sold. Okay, and we can compare them. They're all times 10 to the 9th, so we can see which year more movie tickets were sold. Okay, there was a drop off in tickets sold in 2017. All right, and then movie set format tickets sold, and they do number formatter. Okay, so tickets sold again, they're switching to scientific notation, so this is going to help. And so now we get the commas. I was right, it is billions, okay? And we can even see the cents there, right? So we get the output, just like percent formatter, number formatter, just makes the number look nicer, all right? And it's easier to read. And then movies, we can plot the tickets sold per year. And we can see that the table starts a little bit before 1980 and goes up almost to 2020. And there is a rise in the number of tickets sold all the way up, and then it starts coming down around 2000. There's some big hits in the early 2000s. And why do you think that is? It's an interesting question. What was going on around the year 2000? Well, when the data set starts sloping down, that's about the time that streaming movies became a thing, when Netflix became a thing. And so perhaps people were watching more shows on Netflix and Hulu, and maybe they were spending their time watching movies, but they were streaming them instead of buying movie tickets. That's one possible explanation, but we can certainly see that there's an interesting thing going on just by using this easy method, dot plot. And dot plot shows us a line plot. Okay. Sorry, let me get rid of that ink. And now movies, where year, R dot between 2000 and 2005. And notice that it includes 2000, right? So you say R dot between, so it's including the endpoint. Is it including the endpoint 2005? I don't know if there are any movies that were made in 2005. So what if I do this 2006? Oh, there is a movie made in 2006. So notice what's going on. Just like in the NP.A range, it's stopping 1 unit prior to the stopping criteria here. So there's a couple things we can do. One is we can find the movies that inclusively are between year 2000 year 2005 by increasing this. We also have the ability to do or underscore equal underscore 2. Okay, and when we add this or underscore equal underscore 2 to the r dot between, it does include both endpoints. Okay, so remember the first time it included the first endpoint but stopped just 1 unit prior to the second endpoint. But if we add the or equal to, it will be inclusive. It'll add both endpoints. Okay, and please remember that if you go to your course calendar, at the top, this Python reference, please remember that you can go down here and there is help for all of the tables. And then about the third option down is the table.where predicates, where again, you can see how to use r dot above or r dot above or equal to, r dot between or equal to, r dot containing, r dot contained in. All these things are options for us, and they're summarized in the help file, right? So the help file is the Python reference, which is at the top of the page here in the course calendar. Inferential thinking is a link to our textbook. Python reference is a link to that help file that will help with these r dot between or equal to. And by the way, I don't really remember sometimes whether it includes an endpoint, the first endpoint or the second endpoint. So what did I do? Trial and error. Now, I know that something like this exists, and sometimes I don't have it exactly right in my head. I don't have it memorized necessarily, but I do know that I can go to the help file and I can look at it and verify what needs to be. So movies where the year is 2002 just gives me that row. Okay, movies where year r dot equal to 2002. So again, they're showing what I showed the first time, that when you just put in a value in second, it's assuming that you mean r dot equal to. Okay, right? So we have this r dot equal to predicate. Okay, but if you just put a value in, it assumes the r dot equal to. So it's kind of quick, which makes it actually kind of makes sense too, right? Because if you think of this, this just means, hey, where the year column is equal, has the value 2002 in it. Okay, that kind of makes sense. So remember that the r dot equal to is actually assumed. Okay, again, just makes it quicker to find the rows you want. Now we're going to do where the number one movie r dot containing Harry Potter. Now this is cool because there are lots of movie titles, 7 or 8 of them, that contain the words Harry Potter. And in this particular range, we have Harry Potter and the Sorcerer's Stone, and we have Harry Potter and Deathly Hallows Part 2. Okay, so notice what this does. R dot containing, it's going to grab any row that contains not exactly this text, but at least this text. It has this text plus something else in it. Okay. Now, what's going on here? Where the number one movie column r dot containing Star Wars. Oh, all the Star Wars movies. Okay. And then where number one movie are not containing Menace. Okay, so I guess there's some bias against the Phantom Menace. So we're going to get movies that don't contain Menace but do contain Star Wars. Let's run that cell and see. And you see all of the Star Wars movies except Phantom Menace. Okay. And then what is movies.take? Okay, so first of all, what does NPA range do? So remember, NPA range is going to get us 2, 3, and 4. Remember, it's going to stop at 4, 1 unit before the stopping criteria. So we're going to have this array, 2, 3, and 4. And what's the dot take going to do with 2, 3, and 4? It's going to grab the rows, 2, 3, and 4. So I'm jumping back up to trying to find the original here. This is as close as we're going to get to the original. And so we're going to get rows 2, 3, and 4. But this is row 0, row 1. So the rows we're getting should be 2015 through 2017. 2015 to 2017. Let's see if I was able to guess correctly what this take will do. And there you go. There are rows 2015, 2016, and 2017. So the dot take specifies you give it an array of numbers that you want, and it will grab those row numbers. Okay. And again, they're showing us that the NPA range is what I said it was, 2, 3, and 4. And then movies.take9 is getting one column. It's the 9th one down. No, it's the 10th one down, right? Because remember, the row 0 is going to be the first row. So when we say take 9, it's taking row 9, but remember there is a row 0. So it's actually the 10th row in line. And then remember, movies show 5 is a way to see just 5 lines of the table. And so we went over these predicates with the .where method, and we learned a new method, .take, to get specific rows in the table. And do remember that the computer starts counting at 0. Whenever we're counting things, it's always counting at 0. So let's be rid of the ink and let's see what we're going on to next. So we just have one last table we're taking a look at and one last method we're learning, .plot. Now it's going to create a line plot, which we'll show you in just a second. This new example that we're working on is a recent census. And so we're going to see values in a recent census of the US, and we'll learn how to create these line plots therein. So let's jump to the notebook. Okay, so here is the name of the table, and not so important what the name of the table is, but let's print it out. And wow, so we have census 2010 pop, census or estimate base 2010, pop estimate 2010, pop estimate 2011. So we got all this stuff. And look, 296 rows omitted. So there's something like 300 rows in this table. So partial is the new table we're going to name, and we're going to just get these 4 columns. And we're going to group based on sex. Okay. So holy smokes, there are 102 rows of sex 0, 102 rows of sex 1, and 102 rows of sex 2. That seems really weird because they do actually mean to indicate biological sex, and there aren't 3. I mean, so what's going on? Well, let's take a look. So one thing they're doing here is they're using the .relabeled. That's a new method we haven't shown you. And they're giving a different title to a couple of these rows, a couple of these columns, sorry. Let me print that out. I'm going to remove the ink. Okay, so we've got 2010, we've got 2014, and notice we have age 0, age 1, and age 2. And we're like, what the Sam Hill is this, right? Right? How does this make sense? Um, and they're going to sort based on age. Notice that we have age 0, okay? And here it's easier to see, so I'll show you. Looks like this number, the sex 0, is actually the sum of these 2 numbers, okay? And just guessing that sex 1 might be males and sex 2 might be females, and this sex 0 is the total combined, so everybody in the population. All right, so it's a little bit mysterious how this data set works. And notice there's another weird thing about it. We do this sort, reversed sort, and it turns out that after 100 we have 999s. I'm like, what? What is going on? And I believe these are totals of everybody in the data set, right? So these are 999 means all of the ages, everybody between 0 and 100. That's what it appears to mean. Okay. And so now that we've seen the little idiosyncrasies in this data set, let's see how we do a line plot. Okay. So no 999. Notice that we're just going to do where r dot below 999. And why do we want to do that? Well, again, we don't want the totals messing things up. We just want the individual values for each year old, okay? And now everyone is number 999 where we set sex equal to 0, that's going to be everybody. And drop sex, okay? And then we're going to print this out. And so here we see this is how old you are, 0 years old, 1 years old. And by the way, how are you 0 years old? Well, 0 years old means you're born, but you haven't had your first birthday yet, right? So that's age 0. Age 2, right? You've had your second birthday, but not your third, and so on. Okay, so this makes sense. This is everyone. And look, we're just doing plot the age, okay, and comma 2010. So that's going to put age on the x-axis. Why is age along the x-axis? Because we listed it first. And then the column of data that it's actually plotting is 2010. So this is 2010 data. Okay. And we're going to get something that looks strikingly similar when we run the code below it, which is plot the age. So it's still going to be along the x-axis. Age is along the x-axis, but notice this is 2014 data. But the graph looks real similar, doesn't it? Okay, so what if we do both at the same time? Can we do that? The answer is yes. Now here's the thing. Let me jump back up to the table and show you. So if I say do plot based on age, I just give it the x-axis variable, it will put both things, both columns, along the y-axis. Now the problem with this is if I have a lot of columns, it'll do a line plot for every column of data. So a lot of times we have to do a dot select to get down to just the columns we want to plot. But let's run here and see there are only 2 columns after age. So look what it does. This is nice because it provides age along the x-axis like we think, and it gives us a legend over here and says, hey, the gold is for 2014 data and the blue is for 2010 data. And by the way, these curves look a whole lot alike, except that the gold one is shifted slightly to the right. What? Well, about 4 years, don't you think? Um, so they aren't exact copies of each other, but they're very close, again, because all the 10-year-olds are now 14, and all the 20-year-olds are 24 now. So a lot of the same people are being shown in both lines. And there are some differences in the data set, slight differences in the data set, because sadly, not everybody in the blue line is available to be shown in the gold line. Okay, so those are the new methods that we've got. And this is a really cool one. We use the dot plot, and this showed a really nice way to do the grouping, to do this grouping by only specifying the x-axis variable, and then the y-axis variables are whatever else is in the column. It'll create a line for each and a legend to tell me which colors go with which. Okay, have a great day.